Hey guys, how's it going? So another video on Qwen3.8-27B but this time I am using NINFER as suggested in the comments. Thank you so much. And the difference here is instead of running this on the Mac as a general purpose assistant, I am opting to specify to run it specifically on NINFER, which is like an inference backend where you load a model and it uses your hardware to the fullest potential that it can. In this case, it's specialized for the Qwen 27 billion parameter and the 35 billion parameter models. Now, obviously, we do not have a Qwen 3.8-35 billion. That is Qwen 3.6. So I opted to go for the NFFP4 format of the model, which is around 20 GIBs. Now, if you have a smaller video card, you can opt to get lower quantized versions, such as the 17 GIB version. But I'm assuming that it will just be slightly lower in quality and maybe for different hardware, since NFFP4 is specifically for the Blackwell family. Okay, let's continue. So this is NINFER. You kind of have to install it on Linux. So if you're using a Windows machine, then you would need to use WSL2, which is a virtualization inside of Windows. Or you can use Docker. So I opted to use Docker with virtualization. So first you have to install a Linux and then install Docker and build your Docker image. These days, I don't think anyone really needs a tutorial for this because you can just even get the free version of Codex, ask it to do that for you, and it will set everything up for you. Or if you have a local agent, you can also ask your local agent to set up the environment for you. So NINFER is specialized specifically for the 5090, so I'm not going to be running it on the Mac, but I am streaming off the Mac, so that was a bit of a challenge. And the second thing I am going to be using this with, instead of just, some random harness, I'm opting to use it with the DeepSeek harness. So DeepSeek harness is a very new harness that recently came out, and it is like kind of beta right now, but it is super simple to hook up any model to it. So all you have to do is go to settings, models, and add your provider or custom provider, which in this case is going to be NINFER, which is on the local network on the 5090 over there, and DeepSeek is installed on the Mac. So they're kind of hooked up through Wi-Fi, so it's going to be relatively snappy. Now, I already played with it a bit just to see how well it goes. As you can see at the bottom here, there is an average of 140 tokens per second, and it's not, I did see it go to like around 200 tokens per second, but because we are doing a lot of like creative stuff and my temperature is pretty high, like a 1, then it's not going to be hitting MTP all the time. Also, when it's writing out just words, as you can see here, it's definitely not hitting MTP. So you're going to have like a hit or miss depending on if you're writing code or you're just chatting with it. Obviously, if you're just chatting with it, you probably don't want to use, or like there's no benefit in using such high throughput because it's just going to give you like a chat response. And honestly, Unsloth Studio, anything like 30 tokens per second is fast enough. Like you can't read that fast, especially for this kind of version. I will show you the speed real time just to show you like how fast he goes. And in this case, I had a silly request to go ahead and generate a quick website of a Pelican So in this case, it's a Pelican, and have it iterated on it. And you can see like you can play with it a bit. There's some stats on Pelicans here. Yeah, overall, it's a very good design of a website. Also, I had it run a goal. So in Claude Code and other engines, there's something called a goal or a goal seek or a loop. So what that is you have an initial prompt, and then you can have it go off and continue iterating on that, prompt until a certain, end goal. Well, what that does is generally increase the amount of token usage that you're doing. And normally I've never used that before because I don't normally want to wait like 2 hours for an output. Or if it's a slower model, it's definitely going to be a lot slower than that. So I never really had any use for a goal. But because this model is so fast, honestly, I kind of just had it loop around, see what it does. And the output is quite shocking, and I will show you the difference. Okay, so there's another prompt that I would show you mostly how DeepSeek works. So the reason that we're using DeepSeek harness and everybody is saying that, it is so good is because of its context management. And what that is let's say you can't fit 1 million tokens on your device, right? So you have limited memory. Then you have to, let's say, fit 131 or 65 key context. And if the instruction set how to use different tools takes up most of that room, then you're not able to iterate or generate any useful information in the remaining space. So a good rule of thumb is you need at least 131k tokens limit, or 65k bare minimum. In this case, I have 131, but I'm going to just show you quickly on what it does. So in this case, the compaction works like so. There is a quick breakdown of the summary, and it tells the next iteration of the model of what to do. So in this case, it said, okay, in the V2 scene of whatever panda, I think it was in the process and I stopped it. Either way, there is basically an explanation of what to do, and then it resets the context. So let me just say continue here. And what it then does is goes ahead and generates really quickly its chain of thought. It runs its commands very quickly. It then continues to think. And then at this point it says, well, we have a tool failure, etc. I think we deleted that PNG. Either way, the point is it continues to iterate on the process pretty quickly. And this is real time, how fast it generates tokens at about 164 tokens per second in this case. If you were to lower the temperature to about 0.7, it does go up to 200 tokens per second, but I really power capped my GPU anyway, so I don't really care too much about how the speed past 180 tokens per second. So in this case, it goes ahead and continues to iterate on a prompt. All right, I've been chatting about this quite long. Let me go ahead and show you guys while it's generating here. One, this is the Pelican model here. So it's just a pretty fun web page just explaining what pelicans are, just stats on it, etc. And this was after, I think, 6 generations. All right, now let's go ahead and look at the same as our last video, the Acropolis Pantheon. And in this case, this output was from a 2.4 trillion parameter model, ran locally. It generated about 10 tokens per second, so 10 words per second or so. It took about an hour to get this output. But all in all, this is pretty good for one shot. Basically, it's generating a 3D scene all in JavaScript, CSS, and wrapping in HTML. So overall, this is pretty good. I also had this kind of output generated from the Qwen3.8 2.4 trillion online version. And from the online version, this was the output. And again, this is one-shot online version, and it is, much better than the Q1, or basically the quantized compressed version. So yeah, it is better. There's more buildings around. There are some issues here with the floor, but either way, this is pretty good. Now the next one I'm going to show you is actually the Qwen 27 billion parameter one, but it did run a little loop. So the main point here is, can we approach the level of the one-shot level outputs from a 27 billion parameter model, or a very small model you can fit on any graphics card, almost any graphics card. Like I have a laptop I can fit it on. And what will take to get to this kind of level of performance? All right, so that's the output. And if you are thinking that this is pretty good, yeah, just remember though, this took about 300 attempts. So it kept generating and fixing the stuff probably about 300 times. And I do want to show you guys, what is currently in this file. So this file is about 4,000 lines long. And what else is it? It's about 200 kilobytes its size, and it's all rendering in HTML, all in the browser, with no external libraries. All right, so we can quickly go around this Pantheon here. There, you can see in the background we do have buildings as well, but they're kind of like in pretty good orientation. You can see that there are roads connecting all of them. You can see that we do have hills. We also do have water behind us there. So if I lower the haze, you will see that we do have water. We do have this lighthouse there and some other mountains. We also have wind. So the wind will affect, I believe, the trees. There are small particle effects. I don't know if you can see that, but there are tiny particle effects. You will also notice that we do have a bit of smoke coming off here. And if we zoom in, you can see that there are people or triangles with the head there, and they're all moving around. Now, we also, I believe, have different density of people here. We also have rain. So if we have rain, Then we also have a shader that's more reflective. So it basically makes it a bit wet. And we also have a time of day cycle. So if I were just gonna put it back to where it was here. Now let's look at the time of day. So you can see we do have shadows here. So we got the sun there. And we're just gonna lower it. And so the sun is now setting there in the background. We do see that we get stars. And on the other side, I believe we do have a moon as well. Yeah. So we also have a moon here. And we do have clouds that, you know, also move. I think that, yeah, they are affected by the wind. And what else? Oh yeah, we do have point lights around. So we do have point lights. We got more point lights in the background there. So if I were to go to one of these cities, I think that's the maximum I can zoom in. But there's a bunch of like point clouds. I think that is like a sandstorm or something. And we're back to postcard. Okay, I think that is it. So what I'm going to say now is basically, yes, we can actually get to a level of performance close to, if not, you know, beating the one-shot prompts from these massive 5 trillion parameter models like Fable with loops from a 27 billion parameter model that you can run on basically any graphics card. Now, it will take you longer to get this kind of output because it will have to continue to iterate and improve on the code. But you're basically trading your time for money. Now, unfortunately, I didn't get a chance to get any other kind of examples because I was just basically doing this yesterday and it did have to loop around. But I will be doing a couple of other examples later, hopefully, just to see if it can do other kinds of prompts and how far we can push it on like simple stuff. Yeah, let me know. And again, thank you again for showing me NINFER. That is a great engine that specializes specifically for Qwen 3.8-27 billion for the 5090. And yeah, I'm just going to be using that quite a bit more. Hopefully we get a different version, the 35 billion parameter version. Then the speed will be kind of ridiculous. I think it would be like 700 tokens per second. All right, well, thanks again. And see you guys next time.